All right, welcome to the integration test review. Calculators are not allowed on this test. Some of them you can actually do with a calculator, and that's why you just plug it in and you get the answer, so I don't want you to be able to do that. So that's why calculators are not allowed. So here we go, problem number 1. Approximate the area between f of x equals 2x squared minus 3x plus 5 in the x-axis from 1 to 7 using the left hand, or the left approximation method, and 3 subintervals of equal length. All right, so let's do this. I don't like looking at it like this. I'm going to draw a little picture of what this thing could look like. So we're going to see how well we can draw a picture here. That's sort of okay. So we've got 1, 2, 3, 4, 5, 6, and 7. We want 3 subintervals of equal length. Now I like doing it on a number line to see these intervals, because sometimes people looking at 1 to 7, they get confused about how big the intervals are. So let's see, 1 to 7, that's 6 units. There are 3 subintervals. They are 2 units. Whoops, that is not 2. That is a 2, but that's not 2 units. 2 units wide, like so. All right, and they are of equal length. So there are my subintervals. So these are the bottoms of my 3 rectangles. To determine how tall my rectangles are going to be, we're using the left-hand method, which means we're going to use the left side of each of these rectangles. That means I'm going to be using this side for this rectangle, 3 for this rectangle, the middle rectangle, and 5 for this rectangle over here. So to determine how tall they are, we're just going to plug this number into our equation. So if I figure out f of 1, we get 2 times 1 squared minus 3 times 1 plus 5. This is 1 squared is 1 times 2 is 2. So 2 minus 3 plus 5. 2 minus 3 is negative 1 plus 5 is positive 4. So I plug in 1, we get out 4. And I don't need to draw this really to scale or anything, so I'm just going to put 4 right here. That might be, too little, too much. Actually, granted how big these numbers are, it's probably a little bit. In fact, we'll just, because it's going to cause confusion in the end, let's just say our 4 is really low, really like down here someplace. Okay, not that it matters. Okay, so that's 4. All right, now let's plug in 3 to figure out how tall the middle rectangle is. So let's do this in green. So we got f of 3 is equal to 2 times 3 squared minus 3 times 3 plus 5. So this gives us 3 squared is 9 times 2 is 18 minus 9 plus 5. So 18 minus 9 is 9. 9 plus 5 is 14. So this guy's going to be 14. Once again, I'm not trying to draw it accurately. I'm just trying to get a picture of what it looks like. 14. And finally, let's see what happens when we plug in 5. So we get f of 5. 2 times 5 squared minus 3 times 5 plus 5. 5 squared is 25 times 2 is 50 minus 15 plus 5. So 50 minus 15 is 35 plus 5 is 40. So that would be like much higher, right? Okay, so there are our 3 rectangles, how tall and how wide they are. We're trying to approximate the area. So my curve looks something like, probably something like that. I mean, it is a quadratic, right? So it's going to be something like that. Okay, we're just approximating the curve here. So in this rectangle right here, we've got a height of 4, a width of 2, that's 8 units. In this rectangle, we've got a height of 14 and a width of 2, that's 28 units. And in this rectangle, we've got 40 by 2, that's 80 units. So add all 3 up, we got 80 and 28 make 108, and 8 more make 116. And that'll be our answer for that. If this had been a right-hand rule, I would have used the right-hand side of the rectangles instead. If this had been a midpoint method, midpoint approximation method, and still 3 subintervals of equal length, I would have used the middle of these to determine. So I would have plugged in 2 to determine the height, right? If I had used midpoint. If I had done the trapezoid, I'd want to do left and right, and we'll do a trapezoid down here at some point. In fact, we'll do midpoint too on number 2. So that's the answer to number 1. All right, question number 2. So this is another approximation problem. Says, in fact, we don't need to scroll down that far here. Let's just go right here. Use the table below to approximate the area between g of x and the x-axis from -2 to 14 using the midpoint approximation method. Okay, midpoint approximation method and 4 subintervals of equal length. So we're going to do this one very similar to problem number 1. I know it's the data is given to me in a table, which is nice, but I'm still going to try to draw a picture here. So let's come down here. Let's do a little sketch of what this thing is going to look like. So we're counting by 2's, it looks like, starting with -2, -2, 0, 2, 4, 6, 8, 10, 12, and 14. Okay, and we are doing a midpoint, 4 subintervals. So let's see how we're going to break this thing up. -2 to 14, that's 12 units, right? And we want 4 subintervals of equal length. So what am I thinking? That's not 12 units. That's 16 units. 14 and 2 more, not 14 minus 2. So anyways, each of my intervals is going to be 4 units wide. So here is my first one. Here is my second one. Here is my third one. And here is my fourth one. And since we are doing a midpoint approximation, we're going to use the middle of each of those intervals. So in this case, 0, 4, 8, and 12 to determine how tall they are. So let's start with 0. If I plug in 0 right here, I get out 8. So we'll put a 8 up here, and that's going to determine how tall my rectangle is. Next, 4. If I plug in 4, I get out 11.5. 11.5. There's that rectangle. If I plug in 8, I get out 5. Remember, this doesn't need to be to scale. It's just to give us I like the picture. It just helps be able to see the rectangles and stuff like that. And finally, when we plug in 12, we get out 7.5. So, someplace in here. Like I said, it doesn't really matter the scale. So that's 7.5. So let's figure out how the area of each of these. Now remember, the base here is not 2 units, even though there's 2 tick marks. It is 4 units. So 4 times 8 is 32. 11.5 times 4, without a calculator, let's see, 11.5 times 2 is going to be 23. And so that's going to be 46 if I times it by 4. 5 times 4 is 20, and 7.5 times 4 is going to be 30, I think. 7.5 times 2 is 15, times 2 more is 30. And those all look about right, so that's good. So we've got 32 plus 46 plus 20 plus 30. So let's see, this is 78, and that's 50. So 138. Can I math? Nope. I can't math today. That's 128. There we go. 128. So that'll be our approximation for whatever the heck this function thing looks like. Kind of weird looking, right? I don't care what it looks like, but that's the approximation that we would get using the midpoint approximation method. All right, problem number 3. Says a left Riemann sum, a right Riemann sum, and a trapezoidal sum are used to approximate the value of the integral from 0 to 1 of function f of x. So shown in this picture right here. So we're integrating from 0 to 1. So we're finding the area underneath this curve right here using those 3 approximation methods. Each using the same number of subintervals. Okay. A graph of f is shown below. Which of the sums would give an underestimation? All right, let's underline that so remember underestimation of the value of 0 to 1. Circle all that apply. Okay, so it could be any of these. So let's see. Let's do this. Let's draw this picture 3 times. So here we go. We got this fun little curve all the way to 1, right? So there we go. So let's see. We're going to call this one, let's see, what was the first thing? It was a left sum. So this is going to be, we're going to give our left sum here, a right sum here, and a trapezoidal sum here. And just to make things simple, let's just do 2 subintervals. So if I did 2 subintervals, all right, with a left-hand sum. So here's the bottom of my rectangles. Let's start actually on this side. So I'm going to use the left-hand side of this rectangle. Okay, and then the left side here is basically at the end, so it's going to be a thing of 0. So this is definitely going to be an underestimation. All right, the right-hand sum, same thing. We'll do 2 subintervals of equal length. Right side of this first rectangle, so he's big, right? And this guy is also going to be big, not quite as much, but he's going to be an overestimation. And finally, our trapezoid friend here. Let's come right here, split in halves. And so I go up on this guy, boom, right there, and I go up on this guy, and I connect the dots. So like that, and like that. And that kind of shows you our 2 trapezoids right there. And you can see that this is definitely going to be an underestimation, not by much, but it will be an underestimation. And in this problem, we are looking for which ones would give an underestimation. So our answer is going to be the left sum and the trapezoidal sum. Both give an underestimation with this particular graph. All right, let's take a look at problem number 4. The graph of function f is shown below. What is the value of the integral from 2 to 8 of our function f right here? Okay, so we're finding basically the area under the curve. Keep in mind that because we are integrating from a value of 2 to a value of 8, so we are integrating from left to right, that means that values above the curve are going to be positive, or above the x-axis are going to be positive, and values below are going to be negative. In fact, we'll even throw in some color here, so we'll make that green. So right here, from like, for example, we're starting at 2. Careful, we're not starting at 0. We are starting from 2. So we are going to go from 2 all the way to 8. So we're looking at this stuff right here and this stuff right here. So this green part up here that I've shaded in, this is the value here. We just count boxes. This is going to be 4 units. And this is half of a 2-unit box, so 1 unit. So this is a total of 5. And we've got the red stuff down here. So this triangle is 3 units wide. It's 2 units deep, so that's 6. Cut in half is 3. Now keep in mind, because this is below the curve and we are integrating from left to right, this is going to be a negative value. This is a positive. So 5 plus a negative 3 is 2. If these bounds right here had been switched around and it had said 2 to 8, we would have been integrating this direction, okay, starting with 8 and working our way to 2. And what would have changed is now stuff on the bottom would have been positive and stuff on the top would have ended up being negative. All right, question number 5. If the integral from 2 to 4 of g of x is equal to 4, and the integral from 4 to 9 is equal to 6, what is the integral from 2 to 9 of 2 minus 3g of x? All right, let's try to piece this thing together, because this kind of looks a little confusing at first, but it's not too bad. So let's draw a picture of what g could look like, and it doesn't have to be perfect, but let's just to kind of give us an idea. So here's 2, there's 4, and way over here someplace is 9. And we have some crazy little curve, I don't know, something like that. It's fine. All right, and we know for a fact, because of this equation right here, okay, we know because of this, that from 2 to 4, this area right there is 4 units. All right, and we know from this right here that from 4 to 9, this is going to be, so here's 4, there's 9, this is going to be 6 units. So if you look at what we're trying to find here, is we're trying to find the integral from 2 to 9. So we know that the whole thing is going to be the sum of these two, 4 and 6, which makes 10. We know that this has to equal, or at least I should say, not this guy right here. We know that the integral from 2 to 9 of g of x, that has to equal 10. Okay, not necessarily this thing up here has to equal 10, because this is not just g of x. We got some other stuff in there. But we do know that this has to be equal to 10. So let's take a look at this. We're taking the integral of a subtraction problem, which means we can integrate both of these separately. So we could rewrite this as the integral from 2 to 9 of 2 dx or I'll say plus, and then we'll pull it out in a second, 2 to 9 of negative 3g of x dx. This is an integral, and this is a constant, so we can pull the constant out. So really what we've got here is the integral of 2 to 9 of 2 dx minus 3 2 to 9 of g of x dx. So let's see what we know here. We definitely know this part right here. We know that this is equal to 10. So we have the integral of 2 to 9 of 2 minus 3 times 10, so minus 30. So now let's figure out what this is right here. Well, let's think about this. You could actually solve this using using integration. The antiderivative of 2 is 2x, evaluated from 2 to 9. So we have 2 times 9 minus 2 times 2 gives us, what, 18 minus 4, which is 14. So we got an answer of 14 minus 3 times 10. So 14 minus 30 is negative 16. That's our final answer right there for this problem. Now, another way you could have thought about this is you could have thought of it as a graph. Okay, so here's 2 and here's 9, and the graph of 2 is just a horizontal line at 2, right? So the area between that curve in here, this is 7 units wide, right? 2 to 9 is 7 units, and by 2, so 2 by 7 is 14, giving us the same answer we have here by using the definite integration. So either way works, but our final answer here is going to be negative 16. All right, question number 6. Which of the following definite integrals has the same value as the integral from 0 to 3 of 6x e to the x squared? All right, well, let's look at all of our answers. You'll notice all these answers still have integral signs, but now instead of having x's, they have u's. So it looks like all that we're trying to do here is set up the proper u substitution for this problem. So let's do this. Let's figure out what we want our u value to be. In fact, let me write this equation over here. So we got 0 to 3 of 6x times e to the x squared dx. So I'm looking at this and I'm thinking my u value that I'm going to want is this guy right there, x squared. And the reason why I chose this as my u value, because if I take the derivative of this, I get 2x, and right here I have a multiple of 2x. I can multiply it by 3 and get 6x. So that's what we're going to kind of work for. So we got derivative of this. We're going to take the derivative of this with respect to with respect to x. So we get du over dx is equal to the derivative of x squared with respect to x is 2x. So we get du is equal to 2x dx. Now if you look in our equation up here, to substitute, I don't have a 2x, but I do have a 6x. So you can do one of two things. You could divide the 2 out and just worry about the x dx and not even worry about the 6. Or we can times both sides by 3 and get 3 du is equal to 6x dx. And now we have a clean swap right there. So we've got then the integral. Got plenty of room here. Let's write it over here. Instead of 6x dx, I'm going to write 3 du. So 3 du. We have the e there. I haven't been doing anything with the e, but we did exchange the x squared for a u. So we have 3e to the u. And as I look at these answers up here, granted you can pull the 3 out, right? So I like this one because it's got that 3e to the u. And I like a because it also has that 3e to the u. Now you'll notice the difference here are the bounds. So whenever we do u substitution, you got to remember that these original bounds are x values. They are not u values. So we do need to also change our bounds. So we're going to use this equation right here, the one we set up for as u, to change our bounds. So if I plug 3 in for x, remember these are x values, so 3 squared is 9, so my new upper bound is 9. And if I plug 0 in for x, my new lower bound is 0. And if you look at all those answers then, the one that we like the most is this one right here, answer B. Notice we don't need to solve it or anything, it just wanted us to match which one of these would give us the same answer as that. All right, question number 7. We've got the integral, so this is going to be a definite integral of from negative 2 to negative 1 of t minus 1 over t squared dt. So let's set this up for, make it a little bit easier on us. So we got the integral from negative 2 to negative 1 of t. I'm going to change this to be minus 1 times t to the negative 2, or simply just t to the negative 2 dt. Now as we look at this, it's like, you just ask yourself, do you know how to take the antiderivative of both of these? They're separated by a minus sign, so we do them individually. And I look at this and say, yeah, I know what the antiderivative to t is. It's with respect to t. It's going to be t squared with 1/2 out in front. And I can double check that by taking its derivative. So I'd bring the 2 down, 1/2 goes away, and we're good. This one right here, same thing. I know that I'm going to have the t there. This time I'm going to add 1 to the exponent, so this becomes a negative 1, and I'm going to times, I already got a negative outside, I'm going to times it by the reciprocal of this, giving me a positive 1 out front. And this is the antiderivative of that, and the plus c. But since this is a definite integral, we do not need the plus c, because it would end up canceling out anyways. If you left it, it's not a big deal. But this is the antiderivative of that. Now we're going to evaluate it from negative 2 to negative 1. So we do top down first. So we've got 1/2 negative 1 squared plus, and because I like evaluating negative exponents, I like changing them back to positive exponents. I'm going to change this guy right here back over to 1 over t instead of t to the negative 1. So this is going to be 1 over negative 1 minus 1/2. This time we're plugging in negative 2. We get negative 2 squared plus 1 over negative 2. Negative 1 squared is positive 1. Positive 1 times 1/2 is 1/2. This is going to become negative 1 minus, and let's clean this up first. Negative 2 squared is 4 times 1/2 is 2. And this is going to be minus 1/2. So we get 1/2 minus 1 minus 2 plus 1/2. So 1/2 and 1/2 makes 1. 1 minus 1 is 0, so our answer is negative 2. Okay, problem number 8, and another definite integral. This time when I look at this thing, I ask myself, do I know what the antiderivative of this is? And the answer is no. So that must mean we're going to be using u substitution on this one. So let's decide what we want to use as u, and you kind of look for the inside thing. And if you notice, it's x cubed plus 8. It's on the inside of that square. So I like this idea right here, using this guy. And if we just take a quick look at it, if I take the derivative of this, I'm going to get 3x squared. And I do have a multiple of 3x squared on the outside there. So this is going to be my u value. So we're going to say u is equal to x cubed plus 8. And we're going to take the derivative of this with respect to x, giving us 3x squared, and 8 goes away, right? So if I get the du dx on the other side, 3x squared dx, I've got 6x squared dx. So if I just multiply both sides by 2, we'll be in business. 2 du is equal to 6x squared dx. And now we can substitute the 2 du in for 6x squared dx. Now we also have to worry about the bounds because these are x values, so we need to get new bounds. So my new upper bound, these are x values, so you're going to use this equation right here that we came up with. 4 cubed is 64, and 64 plus 8 is 72. My new lower bound, I'm plugging in negative 2. Negative 2 cubed is negative 8, plus 8 is 0. Now we'll do our substitution. So I'm going to substitute my bounds in. So I've got 0 on the bottom, 72 on the top. We've got the 6x squared dx gets changed out for 2 du. And we've got this middle part here squared, and inside that's going to be my u value. So I'm going to have u squared. All right. And let's take the antiderivative of that. So I know my antiderivative is going to be u to the third power. I already have a 2 out in front, right? So I'm going to multiply by the reciprocal of this. So multiply it by 1/3. And I would have the plus c, but since this is a definite integral, I won't. So it's going to be u to the 0 to 72. So it's going to be 2/3. Let's actually not write it down there. It's kind of encroaching on the next problem. Let's do 2/3, top bound, 72 cubed, minus 2/3 0 cubed. Now, since I did ask you to do this test without a calculator, this goes to 0, that's okay. And this one right here, don't worry about multiplying out. It's just fine the way it is. So we got 2/3 on whatever 72 cubed is, which if you're really bored and wanted to figure it out, when you simplify this all out, it becomes 248,832. But this answer right here is sufficient. All right, problem number 9. This time we're doing an indefinite integral, so we are going to need our plus c on the end. So we've got the integral of secant squared minus sine of x. These are separated by a minus sign, so we can take the antiderivative of each of these separately. And I look at secant squared and I say, yeah, I know what the antiderivative of secant squared is. That's tangent. So tangent of x. And the antiderivative of negative sine is going to be positive cosine. And then plus c. And that right there is our antiderivative. We could take the derivative of that and just double check. That derivative of tangent is secant squared. Derivative of cosine is negative sine of x. Derivative of c is 0. And there it is. That's all there is to that one. All right, problem number 10. We have another indefinite integral, and this time this one's a little bit trickier. I don't know what the antiderivative of that is, so we're definitely going to be using u substitution, and I'm going to use this bottom part, this 1 plus x to the 4th, as my u. And I like that because the derivative of 1 plus x to the 4th is 4x cubed, and I've got a multiple of that up here, so we like that a lot. So we're going to take the derivative of this with respect to x, so we get du over dx is equal to the derivative of 1 is 0. This becomes 4x cubed. Get the dx on the other side, and we get 4x cubed dx. Now, I don't want the 4, so I'm going to divide both sides by 4, and that's going to be 1/4 du is equal to x cubed dx. Don't have to worry about changing the bounds because this is an indefinite integral. So what we really have here is we use substitution is we've got 1/4 du. And this right here, the square root sign, this is a power of 1/2, and since it's on the bottom, I'm going to move it up to the top. So we're going to have a negative 1/2 power right here. And then on the inside of that is my u. And so there is our u substitution now. So here we go. So we've got the antiderivative of u to the negative 1/2 power is going to be u to the positive 1/2 power. I already have the 1/4 out in front. Now I just need to multiply it by the reciprocal of 1/2. Which is 2/1. And don't forget our plus c. So we've got 2/4, which is going to be 1/2. Our u value, the 1/2 power plus c. So finally we need to get it out of u's and back into x's. So my final answer is going to be 1/2 of u, which is 1 plus x to the 4th, to the 1/2 power plus c. And that's our final answer. Don't forget the plus c. Got to have the plus c since it is an indefinite integral. Okay, question number 11. If f is the function given by, whoops, we're missing a little guy right here. We'll call this guy, this is function f. Sorry about that. There's supposed to be an f right there. This integral right here, then the derivative of f at 2 is equal to what? Okay, so we're going to take the derivative of this. So we've got f of x is equal to the integral of 4 to 2x square root. I'm going to rewrite that since I know I'm going to be taking derivatives. I want, well, we won't worry about it. We'll change it later if we need to. Square root of t squared minus t. Wow, that was really a lot more radical sign than I needed. Too much radical. There we go. We want to take the derivative of this. Well, the derivative of f of x is going to be f prime of x. And the derivative of an integral. So whenever we take the derivative of an integral, we can use the shortcut from the second fundamental theorem of calculus, or the second part to the fundamental theorem of calculus, which states that we can just plug the bounds in. So I'm going to plug them in for t. So I have the square root of 2x squared minus 2x. So I have evaluated this at 2x, but then I also need to times that whole thing by the derivative of my bound, which in this case is 2. And then I minus the same thing, plugging in my bottom bound, although for those of you who are kind of looking ahead, this is not going to be necessary, but let's just show it how it works anyways. 4 squared minus 4 times the derivative of 4, which is 0. So this whole thing over here goes away, and this is going to be our derivative right here. So we have the derivative of f is equal to 2 times the square root of, if you're careful, simplify this, it is 4x squared. Don't get too carried away simplifying it, especially if you make a mistake. You don't want to do that. So there's our derivative of f, and we want to evaluate this at 2. So we're going to plug in 2 into our derivative. We get 2 times the square root of 4 times 2 squared minus 2 times 2. We get 2 squared, which is 4. 4 times 4 is 16. I got caught up with myself. Here we go. 16, so that's 16 minus 4. 16 minus 4 is 12. So our final answer is 2 times the square root of 12, which, there it is, E. Now you could simplify this radical more, but that's not part of this, the stuff we're trying to learn. But if this was an actual AP test, they probably would have 4 square roots of 3 instead of 2 square roots of 12, but that's okay. All right, let's take a look at problem number 12. It says find f, or find f of x, if we know that the derivative is equal to 2x minus 5, and we know that if we plug in 2 into our original function f, we get out negative 6. So it looks like we were working backwards. We are starting out with the derivative. We want to find the original function f, so we want to take the antiderivative. So we want to integrate. We're taking the derivative of 2x minus 5. That's what we want to do here. So the antiderivative of 2x is going to be x squared, and I have a 2 out here already, so the reciprocal of 2 will be 1/2, so the 2 goes away. So we just get x squared. Antiderivative of 2x is x squared minus 5x plus c. So here's my antiderivative. Now we do have enough information, so this is going to be our f of x, right? I do have enough information here to go further than this, to actually find my c value. We know that if we plug 2, this is an x value, in for x, we get out an output of negative 6. So f of x is equal to, I don't know why I just wrote negative 6. I meant to write f of x. Okay, so input is 2, output is negative 6. So we know that if we take negative 6, that is equal to 2 squared minus 5 times 2 plus c. This will give us enough information to find c. So we have negative 6 equals 4 minus 10 plus c. Negative 6 is equal to 4 minus 10 is negative 6. That means c is 0 in this case. So our final equation, final answer is not just c equals 0, it's our equation f of x. So our final equation is f of x equals x squared minus 5x plus c, which is plus 0. And there we are. That's called the particular solution. Speaking of particular solutions, it looks like that's what we're doing on number 13 as well. So it says, what is the particular solution to the differential equation dy over dx is equal to x times the square root of y? Given that, if we plug negative y into our original equation, negative 1 into our original equation, we get 25/16. So here we go. This is solving a differential equation is what this is. We want to kind of do the same thing we did up here, except for it's written in dy over dx instead of f prime. So we want to separate the variables. So we've got dy over dx is equal to x times the square root of y. So I want to move everything with x's on the right, everything with y's on the left. So I'm going to multiply both sides by dx and divide both sides by the square root of y, giving us 1 over the square root of y times dy is equal to x times dx. Now from there, what we're going to do is we're going to integrate. So I'm going to take the integral of both sides. To help out with this side right here, I'm going to rewrite this 1 over the square root of y. I'm going to write it as y to the negative 1/2 power. That will help us out a little bit with our integration here. So on this side, we're integrating with respect to y, so I'm going to add 1 to that. I'm going to get y to the positive 1/2. I already have a 1 out in front, but I need to multiply by this, so it's going to be 2y to the 1/2. And we could double check it. If I take the derivative of this, the 1/2 comes down, cancels out the 2, subtract 1/2 from this, and I get negative 1/2, so we're good. Now technically this side also will have a plus c, but we're going to save it, and we're just going to combine it on the right-hand side of the equal sign, so we don't need to put that. Okay. Equals, the antiderivative of x with respect to x is going to be 1/2 x squared. And then let's not forget our plus c. So from this point here, if we were finding the general solution, like I didn't have this extra information, I would just get y by itself at this point. But since we were trying to find the particular solution, we want to figure out what our c value is as soon as we possibly can, which is right now. So we are going to plug -1 in for x, and our output is 25/16, which is our y value. So we have 2 times our y value, which is 25/16 to the 1/2 power, equals 1/2 times our x value squared. Our x value in this case is -1 plus c. Now, at first glance, this might look kind of scary, but it's just the square root of this. So it's 2 times the square root of 25/16. And let's see, -1 squared is +1, so this is going to be +1/2 plus c. Square root of 25/16, I can take the square root of each of these separately. So the square root of 25, because it's division, I can do that. Square root of 25 is 5, and the square root of 16 is 4. So this is really 2 times 5/4 equals 1/2 plus c. 2 times 5 is 10, so this is 10/4. Or if you want to write it as 5/2, which we'll do in just a second. So I really have 5/2 equals 1/2 plus c. Subtract 1/2 from both sides, and we get 4/2 is our c value, which is 2. So our c value is 2. So we come back all the way over here, and we get 2. I'm going to erase the, well, I'll leave those there. That's fine. Just spent a long time, a lot of space, a lot of real estate solving for that c value. So we've got, let me do this in a different color so we can kind of see. So we've got 2y to the 1/2 power is equal to 1/2 x squared plus 2. Now from here, I want to get the y value by itself. So we're going to kind of peel away the onion here. We need to divide both sides by 2. So this becomes y to the 1/2 power equals, divide both of these by 2. So 1/2 divided by 2 is 1/4. Or you can think of divided by 2 as timesing by 1/2 x squared. Divide by 2, I get plus 1. To undo square root, I'm going to square both sides. So I get y is equal to 1/4 x squared plus 1 squared. And that right there is our final answer. Now, interesting though, if this had been a 2 instead of a 1/2, and in order to get rid of the 2, I'd have to square root both sides. If I did the square root, I would have to do the plus and minus sign out here as well in front of the square root, and I would use these inputs here to determine if it was if my answer needed to be positive or if it needed to be negative. Okay, question number 14. A particle moves along the x-axis so that at any time t greater than 0, its velocity is given by v of t. If the particle is at position x equals 4 at time t equals 1, what is the position of the particle at time t equals 2? So you got to be careful because we are moving along the x-axis, but x is not our input. This is an output value. Okay, we got to, so think of it as a y value. This guy right here is my input value. All right, so we're given a velocity. We're trying to find position. So position is the antiderivative of velocity. So if we know that v of t is equal to 2 minus 9t squared, what we're trying to find is the antiderivative of velocity. So what we're going to want to do here is take the antiderivative of both of these. So the antiderivative of v of t is going to be position, which is usually written with an s. You can do whatever you want. I'm going to use an s, s of t. You can do capital V of t if you wanted to. That'd be fine. The antiderivative of 2, so we're taking the integral of this right here. Okay, that's what we're trying to do. So integral of this as well. Antiderivative of 2 with respect to t is going to be 2t. And the antiderivative of negative 9t cubed, t squared, is going to be t cubed with a negative 3 out in front. That will give us our negative 9 plus c. So this is our formula for the position. This will tell me the position anytime I want. It tells me that at time t equals 1, I should be at a position of 4. So I know my position should be at 4 when my t value is 1. So plug in 1 for t into both of those spots. And we'll simplify. So we got 4, I'm going to do it right here. 4 is equal to 2. 1 cubed is 1 times negative 3 is negative 3 plus c. 2 minus 3 is a negative 1, so 4 equals negative 1 plus c. So 5 is equal to c. Now be careful. What's the question asking? What is the position of the particle at time t equals 2? So I don't want to circle 5 because that's my c value. That's not my answer. So let's see. I now know my c value is 5, so I know my position equation. That will tell me the position at any time I want, which I'll check it here in a second, at time t equals 2, is 2 times t minus 3t cubed plus c, which is 5. Now let's evaluate this at 2. So s of 2 is equal to 2 times 2 minus 3, 2 cubed plus 5. So we get 4 minus 3 times 2 cubed is 8 plus 5. So 4 minus 24 plus 5. 4 subtract 24 is negative 20. And negative 20 plus 5 is negative 15. So we are at position negative 15 at time t equals 2. All right, let's take a look at problems 15 and 16. Says a particle moves along a straight line so that at any time t, or from 0 to 10, its velocity is given by v of t, that equation right there. The graph of f, which you'll notice f is part of this velocity equation, right? We're taking the integral of f, consists of a semicircle and 3 line segments, as shown below. So question 15, what is the acceleration of the particle at time t equals 8? Well, acceleration is simply just the derivative of velocity. So I've got v of t is equal to negative t plus the integral of 0 to 1/2 t of function f of x dx. So to find the acceleration, I want to take the derivative of that. So the derivative of velocity is acceleration, so I'm going to write a of t. Derivative of negative t with respect to t is negative 1. And then right here we are taking the derivative of an integral, which means we're going to use that second part to the fundamental theorem of calculus. So we're going to plug our top bound in. So we get plus f of 1/2 t times the derivative of the bound. So derivative of 1/2 t with respect to t is 1/2. So plus 1/2 f of 1/2 of t. My bottom bound is a constant, so in the end it's going to end up being 0, so I don't have to worry about it. So there is my equation for the acceleration. And it wants to know what is the acceleration at time t equals 8. So we've got a of 8, so acceleration of 8 at 8 is equal to negative 1 plus 1/2 of f of 1/2 times 8. So f of 1/2, 8, that's going to be f of 4. So we're looking at a of 8 is equal to negative 1 plus 1/2 of f of 4. And we might ask ourselves, well, what is f of 4? If we look over here, remember, this is a graph of f. This is right here. It says the graph of f is shown below. So at f of 4, so here's 4, we get out positive 2. So this is going to be equal to negative 1 plus 1/2 times 2. 2 times 1/2 is 1, and 1 plus a negative 1 is 0. Shoot. I don't want it to be 0. Oh, well. So that's supposed to be an 8. Darn it. That's going to be 0. You know how much time I put into trying to get this question to work out the way I wanted to? Well, it still didn't work. Let's just make sure. Let's sort of thing. Yep, plug in the 8. Yep. All right, well, my answer is 0. What is the acceleration of the particle at time equals 8? The answer is 0. And you might think to yourself, well, why does he care that the answer is 0? Well, it's going to affect our next problem. But that's okay. We'll learn from this. Okay, so my acceleration at time equals 8 is 0. And then, so if you look at 16, the question says, is the particle speeding up or slowing down at time t equals 8? Well, if it's speeding up or slowing down, that means its velocity is changing, right? Which means that there is some sort of acceleration going on, because that's the change in velocity, right? Well, we know for a fact from problem 15 that at time t equals 8, there is no acceleration. So the question is the particle speeding up or slowing down? The answer is neither, because the acceleration is 0. Now, like I said, I kind of messed up on that because I didn't want my acceleration up here to be 0. I wanted it to be something else. So let's talk about how you would actually solve this one had this been either a positive or a negative value. Okay, something is speeding up. So if something is speeding up, that indicates that the velocity and acceleration have the same sign. They're either both positive or they are both negative at whatever time you're looking at. Okay, slowing down. Okay, we're talking about speeding up or slowing down. The velocity and acceleration have different signs. So one's positive and one is negative. That's how you tell. So let's take a look at this, because if this had been a problem where we wanted to know, if the acceleration had not been 0 or something, we'd want to know, hey, what's happening with the velocity? So let's take a look at here. If I wanted to find the velocity at time equals 8, I would look up at this equation here, velocity of t. So v of 8 is equal to negative 8 plus the integral from 0 to 1/2 times t. Well, t in this case is 8. So f of x dx. So we get v of 8 is equal to a negative 8 plus the integral from 0 to 4. 1/2 times 8 is 4 of f of x dx. Now, if I wanted to evaluate this part right here, I could look at my graph, 0 to 4. That indicates that we are finding the area between the curve and the x-axis. Notice we're starting at 0 and going to 4, so we are integrating to the right. So this is going to count as negative values. In fact, we can figure out whether this triangle is 2 by 4, so that's 8, cut in half is 4. So that's 4 units. And then this part of the circle, all the way up to 4. Okay, we're looking at a quarter circle. So that's 1/4 pi times the radius squared. The radius in this case is 2. 2 squared is 4 times a fourth is 1. So this is pi units. So we have negative 4 plus pi. Pi is 3.14. So that's going to give us a negative value, just barely, like close to a negative 1, right? So we have a negative 8. I guess I can just write it out here. Minus, or I should say plus, a negative 4 plus pi. All right, so this came from there, that right there. This is going to be negative 12 plus pi. It's going to be, who cares what it is? It's a negative number. So the velocity is negative at time t equals 8. So had the acceleration also been negative, then the particle would have been speeding up because they had the same sign. If the acceleration had been positive, then they would have been slowing down, since the velocity and acceleration had different signs. So that's how you would have solved this one had this acceleration actually worked out the way I wanted it to and have a number other than 0. But of course, the one number in the universe that makes this problem not work, it happened to be that thing. I'm not bitter about it. I'm not at all. Maybe a little bit. Okay, so that ends the actual test review portion. Now, because some of these problems are like very unique, there's only one problem on the test that's like it, I have provided a couple of extra practice problems that you're welcome to do. So this first problem is going to be similar to question number 1. So it says approximate the area between the f and the x-axis from -1 to 2 using a right-hand method, 3 subintervals of equal length. So let's see, let's draw a little number line here. We've got -1, 0, 1, and 2. And we are making right-hands. So this is rectangles, and they are 3 subintervals of equal length. So there's 1 subinterval, 2 subintervals, and 3 subintervals. We are using the right-hand method, which means that for this first rectangle, I'm going to plug in 0 into this equation. So I plug in 0, and we get out -2. Well, that's unfortunate, too. What a piece of junk problem is this? Who cares? So we are finding the area. So yeah, this does give us a value of -2, which I didn't want it to do. Gosh, plans just fall apart. So there's my rectangle right there. Okay, plugging in +1 for this rectangle, we get negative, so this is f of 1 is equal to -2 times 1 squared minus 4 times 1 minus 2. This is 1 squared is 1 times -2 is -2 minus 4 minus 2. So we get -2 minus 4 is -6, and we get -8. I guess this isn't going to be too bad. I didn't want them switching signs, but that's okay. Notice I did not prepare for those negative signs. It's gone the other way. That's okay. And f of 2 is going to be -2, 2 squared minus 4 times 2 minus 2. 2 squared is 4 times -2 is -8. Minus 8 minus 2 gives us -16. Minus 2 is -18. So this guy way down low to -18. Now, if you read the question, well, actually, let's figure out these areas really quick. So this is a width of 1 and a height of 2. So this, and a height of -2, if you will. So this is going to be -2. Okay, this one right here is width of 1, a height of -8. Width of 1, height of -18. Now, if you look at the question carefully, it does say to approximate the area. Okay, so when we're doing area can't be negative. So even though these are going to be negative values, I mean, we're just finding the area between the curve and the axis. So we're going to treat these all as positive. That's why I got kind of upset at the beginning, because I thought it was going to be one was going to be negative, one was going to be positive, and I was going to be very upset with myself. So, but they are not, so it's okay. So we have -2 plus a -8 plus a -18. What gives us -28. So the area, since area has to be positive, is going to be positive 28. Now, if I was finding, you got to understand the difference between this and finding the actual integral. If I was finding the actual integral of f of x, okay, from -1 to 2, and let's say that let's say that this actually is the area or whatever, like the exact value or whatever. Then my answer would be a negative value. It would be a -28 because we are integrating, and values below the x-axis when we integrate are negative. When we integrate from left to right are negative, and values above are positive. So, you know, you got to be careful with what we're asking. We are asking for the exact area, or I should say an approximation of the area, and area is always going to be positive. All right, let's take a look at this next problem. Problem similar to question number 2, and see what we messed up on this one. So here we go. So we've got, we're counting, let's see, x value is counting by 5s all the way up to 50. So we got 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. And we are using, I guess I got to read the directions. Use the table below to approximate the area between G and the x-axis from 5 to 50. Okay, so we're doing the whole span here. Using the trapezoid approximation method and 3 subintervals of equal length. So 3 subintervals, so 5 to 50, that's 45 units. Cut into thirds is 15 units each. So we're going from 5 to 20 to 35 to 50. So there's the bottom, the bottom of our trapezoids right there. Now, to figure out the height of our trapezoids, we are going to plug in not only the left side, but also the right side. So if I plug in 5, I get out 2. So I'm going to put a little 2 there to help me remember. If I plug in 20, I get out 10. Remember, this doesn't have to be to scale. It's just to kind of help us gauge what it looks like. And there is our first trapezoid. Next one, I've already plugged in this side, so I'm going to plug in 35, and I get out 26. there's our next trapezoid, and I plug in 50 and I get out 34. I want to find the area of those trapezoids right there. The equation for the area of a trapezoid is you take base 1 plus base 2, cut in half. So basically I'm finding the average of these two lengths right here. The bases are the sides that are parallel to each other. And then I times it by the height, which is defined as the distance between the two parallel sides. So for example, this first guy right here, we'll do this one in green. Okay, we've got 2 plus 10 divided by 2 times the width, which is 15, plus, we'll do this one in magenta, pinkish, purplish, whatever color that is, plus 10 plus 26 divided by 2 times 15, plus this guy right here is 26 plus 34 divided by 2 times 15. So let's see what we got here. 2 plus 10 is 12, divided by 2 is 6. So we have 6 times 15 plus, it's going to be 36, so 13 times 15 plus 26 and 34 make 60, divided by 2 is 30, so plus 30 times 15. And you know what? I am too lazy to figure those out by hand, and I know it said no calculator, but you know what? I wouldn't give you those big of problems on an actual test. So 6 times 15 is 90. Where's my green? 90. 13 times 15 is 195. Ain't nobody got time for that. 30 times 15 is 450. That's the wrong color. Plus 450. Add them all together, and you get a big number. 735. Ding, 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 ding. There is our approximation. But if you look really carefully, you can see that we made a mistake. And 10 plus 26 is 36. Divided by 2, which is 18. So this should be an 8. And 18 times 15 is not 195. It is 270. So that makes a little bit of a difference to our final answer. 270 plus 90 plus 450 is actually 810. See, this is why you don't use calculators, because they give you the wrong answer. Just kidding, that was my fault. I didn't use a calculator. And yeah. So 810, final answer. For reals this time. All right, next problem. This one is similar to question number 5. So we've got the integral from -1 of 8 of f is 7, from -1 to 5 is 2, and we're trying to figure out what 5 to 8 is of this mess right here. So let's see what this guy would look like. Let's take a look at what this thing looks like, at least with f. So I'm looking at f right now. So from -1 to 5 to 8. So we know from this guy right here that the entire thing from -1 to 8 is going to be 7. And we know this guy right here from -1 to 5 is going to be 2. So maybe it looks something like, you know, I don't know, woo, and then woo, like that or something, I don't know. So we have -1 to 5 is 2. And it's kind of hard to see that, isn't it? So let's do a little black line in there, is 2. And then we know the whole thing is 7, which means that from 5 to 8 in there, if it has to equal 7, this thing in here should be 5. All right, so let's add a little black line in there so you can see it. It is 5. Now, so we know, let's write this out. So we know the integral from 5 to 8 of our function f, we know is going to be, by these first two equations, we know is going to be equal to 5. So we know that for sure. So let's take a look at this and let's see how that helps us. So this is two things being added together, so we can separate these out. So we want the integral from 5 to 8 of 4 dx plus the integral of 2 f of x dx from the same bounds, 5 to 8. I can pull that 2 out, so we have the integral from 5 to 8 of 4 dx plus 2 integral 5 to 8 f of x dx. We know from this right here that this part right here is equal to 5. So we have 2 times 5. Then we have the integral from 4 from 5 to 8. So we can antiderivatize that thing. So we get 4x evaluated from 5 to 8. So what is that? 32 minus 20, which is 12. Okay, so this is going to be 12 plus 2 times 5 is 10, gives us 22. Final answer. Okay, problem number, the one similar to question number 7. We've got a definite integral here, and these aren't too complicated, so we don't need to use substitution here. So we've got the integral, I'm going to rewrite this 1 to 2 of 4t. The reason why I'm rewriting is because of that guy right there. Write this to t to the negative 3 power. So this is sum. So we can do the antiderivative of these separately. So the antiderivative of 4t with respect to t is going to be t squared. And then we have the 4 out in front, so I'm going to need a 2 out in front to make it when I take the derivative to get that 4. Then I've got t to the negative 2. I already have an 8 out in front, so I need to multiply it by the reciprocal of that. So that's going to give us 2t squared minus 4t to the negative 2. Let's just double check that. That derivative of that is that. Will look good. Derivative of that's going to be positive 8t to the negative 3. Sweet. Plus c, but this is a definite integral, so we don't need the plus c. So we are going to evaluate that from 1 to 2. So using the fundamental theorem of calculus, we plug in 2 minus 4, and here's a negative exponent. I'm going to evaluate it like this. Plug the 2 and put it squared like that. Minus 2 times 1 squared minus 4. 1 over 1 squared, and like that. So we got 2 squared is 4 times 2 is 8. So this is going to be 1/4 times 4, negative 4 is going to be negative 1. Minus 1 squared times 2 is 2. 1 squared is 1, so minus 4. So we get 8 minus 1. 2 minus 4 is negative 2, so plus 2, and we get out a value of 9. And that's the answer to that one. All right, next problem. This one is similar to question number 8. This is a definite integral, but with a little bit more confusing integrand right here. So we're going to want to use substitution on this sucker. So let's see. Well, here's the inside right there, sine of theta. So let's set that equal to u and see what happens. So u equals the sine of theta. The derivative of u with respect to theta is equal to the derivative of sine is cosine of theta. So get those on the same side. We get du is equal to cosine of theta d theta. Now I look up here. I do have a cosine theta d theta, so I could change it out right now if I wanted to. But you know what? I want to get rid of that 3 while I'm at it. So I'm just going to multiply both sides right here by 3. So what we can do now, oh, and then I need my bounds, right? This is a definite integral, so I do need to change my bounds. So my new upper bound, and I'm plugging in pi into this, so sine of pi is 0. And my new lower bound, pi halves, sine of pi halves is 1. So we've got the integral. New lower bound is 1, new upper bound is 0. 3 cosine d theta goes away and gets replaced with 3 du. Here we've got the square root. I'm going to change that to exponent 1/2. Okay, and inside is my u. And now I can just take the antiderivative of this. The antiderivative of 3u to the 1/2 power is going to be u to the 3/2 power. I already have a 3 out in front. Now I need to multiply by the reciprocal of that, which is 2/3. And we're going to evaluate that from 1 to 0. So this simplifies to be 2, so that's nice. So this is going to be 2, plug in 0, 3/2, minus 2, plug in 1, 3/2. So remember, 3/2 just means take the square root and then cube it. So we're taking the square root of 0, which is 0 cubed is 0. So this whole thing goes to 0. That's nice. The square root of 1 is 1. Cubed is 3. Cubed is 1. Golly. tired. 1 to the third power is 1, so we got negative 2. So my final answer is negative 2. All right, next problem. Problem number similar to 11. It's now that I have to really watch myself that I don't make mistakes because I can smell the end. We're almost there, and that's when I start making mistakes. Not that I haven't made plenty of mistakes already. All right, similar to 11. If f is the function given by, golly, there's that stupid thing again. We're calling this f. Sorry, there's a missing f right there. We've got a definite integral here. Okay, then we're trying to find the derivative at negative 1. Okay, so we want to take the derivative of this. So the derivative of f of x is f prime of x. And then we have to take the derivative of an integral. So this is going to be the second fundamental theorem of calculus. I have variables in both bounds. This is going to be fun. So I take the top bound, I plug it in. So I get 5, plug in 2x cubed, and I'm going to cube it, times the derivative of the bounds. So that's going to be what, 6x squared? Minus what happens when I plug in x. So 5x cubed times the derivative of x, which is 1. So there's my derivative. I wouldn't simplify it more than that. I'll just leave it like that. We want to plug in negative 1. So let's throw some color into this. F prime at negative 1 is equal to 5 times 2 times a negative 1 cubed, that whole thing, cubed, times 6 times a negative 1 squared, minus 5 times a negative 1 cubed, times the 1 doesn't do anything. So we get, all right, 5. Negative 1 cubed is negative 1 times 2 is negative 2. Cubed is negative 8 times, negative 1 squared is positive 1, so that's going to be times 6. Negative 1 cubed is negative 1 times 5 is negative 5. That is going to be plus 5. And we get 5 times negative 8 is negative 40 times 6 is negative 240 plus 5 is negative 235. Final answer. All right, let's see what we got here. Question number 12, or one similar to question number 12. Find f if f prime is equal to this, and we know this. So we're looking for the particular solution for f. So the antiderivative, what we're going to be doing is the antiderivative of those things. So the antiderivative of prime is going to be f of x. Antiderivative of negative 4x cubed is going to be negative x to the 4th. Antiderivative of that's going to be plus x squared minus 3x plus c. Now, we know that if we plug negative 2 in for x, we get out to negative 3 for f of x. So we know this is going to be equal to negative 3 if I plug negative 2 in for x. So we get minus 3 times the negative 2 plus c. So we get negative 3 is equal to negative 2 to the 4th power. It's going to be 16, so it's going to be negative 16 plus 4 plus 6 plus c. So we get negative 3 is equal to negative 6 plus c. Add 6 to both sides, and we get 3 is equal to c. So our final answer is going to be f of x is equal to negative x to the 4th plus x squared minus 3x plus 3. And there is our final answer. All right, question number 13, or the one similar to question number 13. We are doing a particular solution here to the differential equation dy over dx is equal to 2xy. Knowing that if we plug a 4 into our original equation, we get out negative e. That's nice. So we have dy over dx is equal to 2x times y. So we want to separate the variables. So we get 1 over y dy is equal to 2x dx. Then what we want to do is we want to integrate both sides. This side with respect to y, this side with respect to x. The antiderivative of 1 over y is the natural log of the absolute value of y plus c, but we'll save it for the right side. Antiderivative of 2x is x squared plus c. Now we know for a fact that if we plug in 4 for y, we have to get out negative e for x. Whoops, I got those backwards. See, I told you I could smell the end. It's coming. I get out a negative e when I plug in 4. So let's try that one more time. So we get the natural log of the absolute value of negative e is equal to 4 squared plus c. Well, the absolute value of negative e is just plain old ordinary e. It's equal to 16 plus c. Natural log of e is 1. So 1 is equal to 16 plus c, meaning that c must be equal to negative 15. So we've got now we know our c value. We'll come back over to this equation. Let's do it another color. We get the natural log of the absolute value of y is equal to x squared minus 15. Now we'll rewrite this. The natural log of y is equal to this. So this is, if we treat these both as, the powers of e, and those cancel out. So we're left with the absolute value of y is equal to e to the x squared minus 15. To get rid of the absolute value of y, we just treat this side as plus or minus. So y equals plus or minus e to the x squared minus 15. Now, I do need to figure out which one it is, plus or minus. So I'm going to use my my information that I know here. I know that if I plug in 4 for x, I need to get out a value of negative e. Well, if I plug 4 in for x, I get 16 minus 15 is 1. So I do get e to the first power, which is good. I do need it to be negative e, so I know that my answer needs to be the negative version, not the positive version. So there is our final answer. And finally, we are to our last problem. A particle moves along the x-axis so that at any time t is greater than 0, its velocity is given by velocity of t equals 2 minus 9t squared. If the particle is at position 7 at time t equals 1, what is the position of the particle at time t equals 2? So position is the antiderivative of velocity. So we want to take our velocity equation, and we do want to find the antiderivative of that. So the antiderivative of velocity is going to be position. Antiderivative of 2 with respect to t is going to be 2t. And this is going to be t cubed and going to be minus 3. So that gives us that right there. And don't forget the plus c, right? Now that looks familiar. Oh, I'm so lazy. Oh, this is just the same thing as it was. Problem 14 is the same thing. It's just, we got a different time, and I'm so lazy. Okay, it must have been a different, we'll probably get a different c value though, so we got to be careful. Okay, so here we go. But that's the same equation I used on the actual problem 14. So here we go. If I plug in if I plug in 1 for t, I get out a position of 7. So I know I get position 7 when I plug in 1 for t. So we're going to find our c value here. So 7 is equal to 2 minus 3 plus c. 2 minus 3 is a negative 1, so if I add 1 to both sides, I get 8. 8's our c value. So we know that our equation is s of t is equal to 2t minus 3t cubed plus 8. Now the question asks, what is the position of the particle at time t equals 2? So we do want to take our equation here, and let's plug in 2. So we got s of 2 is equal to 2 times 2 minus 3 times 2 cubed plus 8. So we get 4, 2 cubed is 8, minus 3 is negative 24, plus 8. So we get 12 minus 24 is negative 12. That is the position of our particle at time t equals 2. And that is the end of the video. I hope you enjoyed it.